Hey everyone, so today we're going to work on applications of exponentials and logs, aka word problems, your fave. So let's get started with two major equations we're going to need, or formulas. So we've got this guy, a equals p times 1 plus r over n to the nt, and then a equals p times e, this is the number e, 2.718, etc., to the rt. This is used when we're compounding continuously. Okay, so what we're going to be talking about is interest compounding continuously here, or compounding, whether it be continuously or perhaps semi-annually or quarterly or monthly. So we're going to have a couple things we need to know here. Again, this is kind of problems that are going to talk about if I invest this much into an account with interest at this rate and they compound that interest or add that interest every month, what would I end up with my final amount? So that's kind of the general idea of these formulas. Okay, letter representations here. A is that final amount after t years. T is always in years, by the way. So variable represents time, little t right there. Then you've got P. This is the principal or initial amount. So if I said I invest $1,000 into my account. R is the rate as a decimal, so not the percent. So if I said 5%, I would write that as 0.05. So just be careful on how we write those for R. N is kind of the new situation here. So this is representing the number of compoundings, meaning this would be like if I said I compounded quarterly, how many times a year does that happen? 4. Monthly, that would be 12. Weekly, there's 52 weeks in a year. Daily, 365. Semi-annual comes up sometimes. Semi-annual would mean twice a year. So those are some other ones that come up, kind of just depends. And we'll see some more, and they should be things that you know. So that's the equation for compounded at different amounts of time, daily, monthly, whatever it may be. If it says compounded continuously, this is where that equation comes in. So P, R, and T have the same meaning, but notice that N is not involved. And we have this, it's PERT, kind of looks like, so easy to remember. E to the RT is for compounding continuously. All right, so let's try this out. We're going to look at part A. You guys should have your calculators out, preferably if you have a graphing calc. That's probably the easiest thing to use. Just because it types in fractions nicely, you can kind of type everything in one swipe. I would not recommend using an iPhone, iPad, phone calculator for this. Definitely want to be using some type of graphing calculator or at least a nicer TI 30 something. So suppose 1,000 is deposited. So this is the principal amount into an account that pays 4%. So R would be 0.04 interest per year. Find the amount in the account after 10 years. So this would be, what is A? T is 10, and the interest is compounded quarterly. That would mean N is equal to 4. So we've got our little equation. We're just doing part A right now. So A equals P times 1 plus R over N to the NT. So we've got A, we don't know. We want to know. If we deposit 1,000, 1 plus 4% over N was 4 for quarterly, to the 4 times 10. All right, so you should be able to type all of this in at once. Again, maybe the only thing I would change if I were you would be setting this to 40 maybe. You don't want to be careful. It's not 1 plus that, it's 1 plus space. This is its own fraction. So don't try to add the 1 into that fraction. All right, so give yourself a second, try typing it in. You should get, we're going to do money here, so we want to round to 2 decimal places because we're talking about money, 1488.86. All right, so if you invest $1,000 and you have this 4% interest, you wait 10 years, you now end up with $1,488.86. Okay, so for part B, it says how much interest is earned. Well, think about it this way. If you started off with $1,000, okay, and now you're at 1488.86, all you're going to do there is decide how much interest was earned, just subtract from your original amount. So you earned 488.86 for just your money sitting in this invested account. Okay, so how about part C? What if we change this up? We took our money, so still P is equal to 1,000, still 10 years, but what if we compounded continuously? So that's A equals P times E to the RT. All right, so we're going to try this out. So what if we did that instead? 1,000 times E to the 0.04 times 10. Okay, so in your calculator, when you type this, it should give you like E to the, and then I would just put parentheses around 0.04 times 10. Or just make sure it's all in the exponent, kind of depending on what calculator you guys have. Give yourself a second. You should get A is equal to 1491.82. So it's actually more money, a little bit more money if you did compounded continuously. So that might be the account you choose if you had a choice. All right. So take a look at example 2. Okay, we're going to try a few more here. Example 2 says you want 6,000 in 5 years. So 6,000 is the final amount. That's A. 5 years would be T. How much should you deposit today? So that's, we don't know how much we want to deposit. So that would be P. What's the principal amount we want to put into the account so we can grow it, or the final answer, or that final A, is 6,000. Okay, 3.1, let's be careful here. R equals 0.031. 0.31 would be 31%, so be very careful. Compounded semi-annually, that happens twice a year, like a semi-annual sale. And in order to have 6,000 in 5 years. Okay, so when we set this up, we've got A, again, if you want to rewrite the equation, 1 plus R over N to the NT. 6,000 equals P times 1 plus 0.031 over 2 to the 2 times 5 years. All right, so if I was looking at your work, I should see that set up perfectly. We're solving for P, and P is, it's this times this whole thing. So if we want to get rid of that parentheses, we're actually going to divide by that whole thing. I don't want you to type into your calculator yet, because then you get a rounded answer, and that kind of sets us up for having some issues in terms of getting an exact answer. So all you're going to do, you can divide by this whole thing, okay? I don't want you to think I didn't type anything in yet, so actually I'll just write it exactly. 0.031 divided by 2 to the 10th, I guess I'll write that. We're going to divide both sides by that, okay? I'll even copy and paste just to be efficient with you. We won't say lazy, okay? So we get, all right, in general, if I said what's the exact answer, P would be 6,000 divided by 1 plus 0.031 divided by 2 to the 10th. All right, and that's what you should be able to type in. Remember on TI-84s, you can click in alpha y equals to get a fraction. If you're on any other calculator, please just make sure you have parentheses around this appropriately. It should be fine though, 6,000 divided by that whole thing. Think about it this way, guys. You're trying to find the answer of what should I invest to get 6,000. So if you get a number like 50,000, that doesn't really make sense, right? Because then you invested 50,000 and only got back 6,000. Seems like kind of a bad account to have. So you should be getting something less than 6,000, and you shouldn't be getting anything that's like $2, right? If I invested $2 and I only get 3.1%, I'm not going to grow to 6,000 in 5 years. So hopefully you get something realistic here. Specifically, you should get this exact answer, 5,144.60. And this makes sense, right? You're only doing 5 years. You want that amount to grow to 6,000, and it's only getting 3.1% interest. So hopefully that makes sense to you, that that's an appropriate answer here. You shouldn't get negative money. You shouldn't get, P should always be less than A, right? A should be the final amount it grew to. So P should be a smaller number. Okay, we're going to save part B for class. So hold on to that. Example 3 and example 4 will be our final examples here. Okay, so take a look at example 3. It says how many years, so T equals question mark, will it take the principal in an account that is compounded continuously? All right, that means I'm using this equation. At 3%, R is 0.03, to double. All right, well, they didn't give us A or P, so that's kind of weird. But here's what I want you to think about. This is just a general idea. So if I said, how much time will it take the principal to double? You can make up whatever amount you want. So what if the principal was $100? Okay, then I want the final amount to be $200. I also could say $10 and $20. I also could say $1 becomes $2. This is actually my recommendation. I'll show you why. Use the smallest amount. I just think that's kind of easiest. You've got A equals P times e to the RT. 2, when does that grow from 1? Okay, why did I pick 1? By the way, I'm sorry, I should plug in 0.03 times t. I picked 1 here because that goes away. And now we're ready to actually solve for t. If you plugged in, I'll show you one more example because it really doesn't matter what you pick here. So what if I picked, I invest $100 and I want to get back $200. This would be perfectly fine. And it doesn't matter, again, what you pick as long as it's doubling. If I divide by 100, that's what I should do to start this problem. What do I get? 2 equals 1 e to the 0.03t. So either way, you're going to come to this moment. Doesn't really matter what you picked for A and P, which is why maybe it's easier to just pick $1 and $2, even though it's a pretty small investment, but hey, whatever. All right, how do we solve for something in the exponent? We're going to be using our friend logs. So you can use regular common log, or you can use natural log. Since we have e involved, highly recommend using natural log. Okay, so we get natural log of 2. Remember, this comes down to the front, so 0.03 times t, and then times natural log of e, which just cancels, right? Natural log of e is 1. So, again, right now we have natural log of 2 is equal to 0.03 times t. So just divide by 0.03 on both sides. So t, is equal to natural log of 2 over 0.03. Try typing that in. Remember, this is the amount of years. So you want to know an amount of years. Should be positive. Let's round to 3 decimal places, actually, since we're talking about years here, not money. I've got 23.105 years is how long that would take. And again, I know that sounds kind of silly to go from $1 to $2, but if you think about 1,000 going to 2,000, maybe that makes more sense, that if you're only getting 3% interest, it's going to take you a while to actually double that amount. But hey, the money's sitting there gaining interest, so that works. Okay, last problem we're going to do is number 4 here. We'll save number 5 for class about your popular Instagram account. So number 4, exponential growth and exponential decay. We've obviously talked about this, what it looks like in a graph. 2 to the x, 3 to the x for exponential growth. Then you've got, 1/2 to the x, 1/3 to the x for exponential decay. So I don't want you to get confused. It's actually a really, really similar formula here. You have the final amount, initial amount, the rate in decimals, and time. Really what's missing, do you guys notice this? We just don't have n. Like we don't have r over n, we don't have nt. So it's actually just kind of a simpler version of this. Reason for that is it's like per year. Think of it as like annually, so n would be 1. But these are the equations, and I don't want you to get confused because we're just not going to use money in these equations the same way. Like we're going to talk about not interest rates, but like the rate at which a car's value is depreciating, or maybe how fast your Instagram follower count is growing, something like that. So something that's not interest, money, account related, we'll use these 2 equations. So the only difference here, if you are growing, you're doing 1 plus r. If you are decaying, or it's depreciating, going down, you've got 1 minus r, the rate of decay. So take a look at example 4. You bought a car for $10,000. That would be the initial amount, which in this case is lowercase a. I'm sorry to use different letters. I'm just going to go off of these 2 equations here. The car is depreciating, or decaying, I know that sounds a little bit dramatic, at a rate of 0.25, 0.025. 2.5%, 0.025. Find the value of the car after 5 years. So we're going to look for y, which is the final amount, after 5 years. Okay, you've probably heard this before, right? You buy a new car, you drive it off the lot, it immediately loses value. And it loses value every year you have it, right? A 20 car is more valuable than a 2015 car. So depending on that situation. So we've got y equals 10,000, the initial amount, 1 minus 0.025. Why did I subtract? Because we're decaying. The car isn't gaining value. The car is losing value, unfortunately, to the t, so to the fifth. All right, again, you have your calculator right next to you. Should be able to just type this right in. So let's see, we've got 10,000 times, honestly, I wouldn't even rewrite it. I would just write your final answer here. It looks like we've got 8811.0. I'm sorry, I wrote my answer wrong on the answer key, so we'll have to double check that one. But anyways, hopefully you're getting that answer there, 8,811. My cents might be wrong. I will fix that. But long story short is, does that make sense? I always kind of want you to think about, does this answer make sense? Well, yeah, right? It was $10,000 car. That's great. But then after 5 years, every year it goes down in value a little bit. So specifically now it's down to $8,811. So that's about it, guys. Thank you so much for watching. We'll try example 5, where you are growing followers. We're going to have a positive rate for that one, and we're going to talk about exponential growth. And yeah, thank you. Let me know if you have any questions.